Hey everybody, just wanted to welcome you to the next video in my YouTube Codesys YouTube series. Today we'll be talking about data types, basic and more advanced data types. So we're going to look at just the basic data types and what are the different options and why we have them, and then we're going to move on to more complex data types like arrays and user-defined structures and how we use them. And in the process, we're going to see how to use indirect addressing, and actually I'm going to leverage the global variables again and see how they work. All right, so let's get started. So this is our basic program that we've had from all through the series of the videos. And again, we just have push button 1 and light 1. And of course, we have declared them as a data type Boolean. Well, what is a Boolean? What is a data type Boolean? What are we actually doing? I think everybody understands a Boolean is a single bit. But let's think of it maybe as a little more than that. What is a Boolean? And for that matter, what is an integer and what is a real or a floating point? What are these data types? And in any PLC and any computer for that matter, PLC is nothing more than just a computer. A data type is really for the human. It's not for the machine per se. The machine itself, everything we do, everything you see on the screen ends up getting compiled into what's called machine code. So ones and zeros. It gets compiled to ones and zeros, and then that's what is actually downloaded to the computer. So behind the scenes, everything's converted to ones and zeros. So really, in the end, these data types that we see are really for us. And it's so that we can maybe optimize the memory of the PLC a little bit. So why use a dent or a real when we can express it in just a Boolean, one single bit? So instead of using a dent, which would be 32 bits, why don't we just use 1 bit instead of for a Boolean? So that's the point, is that these data types have different structures for a reason, different sizes. We need them for those sizes, but we can also optimize and use the smaller sizes when we need to. We can use a dent for a 32-bit word if we want, or we can go a little smaller if we don't need the memory, if we don't need the capacity, we could use an int instead, or for that matter, maybe we can use a cint, which is a single integer. Okay, well, let me go and let me make a tag and let's look at that. So my tag, for argument's sake, I'm going to make it a dent. If I right click here and go into input assistant, you'll notice it gives me the option to go through the standard types that are available for this tag. So a lot of different types, and I'm not going to go through each one of them or what they are. If you really want to find out more about them, you should go online and take a look. But for example, you've got Boolean, you've got a single byte, a date and time function, a dent, a double word, an integer, a long integer, a long real, a real and a single integer, and simply a time and time of day, and some unsigned integers as well as and words. So there's a couple of them anyways that we're talking about. But let's go and make this a dent. So I'm going to say I'm going to make that a dent. And sure enough, I've made that just that basic data type, that basic tag with a standard basic data type, a dent. Nothing crazy there, right? Okay. So we know up till now we can make a standard tag, which is just one single data type or one piece or one element. We know when we make a timer that it is actually it has some parts to it. There's a Q, there's a PV, and there's certain parts to it. Well, a timer and a counter for that matter, they are what we've referred to as structures of information or structures, and those structures are configured to work with. In the case of a timer tag, it's configured to work with a timer. In a counter tag, it's meant to work with a counter, obviously. So we have structures that we use for certain purposes, counters, timers, and so on. We can make our own structures, and there's several forms to this. The first type that I want to actually talk about is something called arrays. What is an array? What can we make in an array? What exactly is an array? An array is actually as the name implies, is a block of, in this case, memory in the PLC that we're able to actually put data into it. Now, in all my other PLC classes, I do Rockwell PLC classes, I do Siemens PLC classes. Whenever I do these other classes, they also have arrays. Most computer systems of any type today has this option built into it. It's a standard programming technique to use arrays. Now, so in these other classes, I actually talk about, I use the same analogy in all of them, how to understand arrays. What is an array? Well, the classic definition is it is a grouping of like data. It's a grouping of like data. Well, you know, that doesn't really explain too much. It will in a minute, but it doesn't really, at first glance, doesn't really give us an impression of what this is. Okay. Well, sure enough, an array is a tag. Absolutely. But it's a tag based on a block of memory that we're able to write into portions of it. Much like an Excel spreadsheet, let's say. An Excel spreadsheet has rows and columns that you can actually write into. Well, an array, you can visualize it just like that. The other way, and again, the example that I use in these other classes is actually is an array of mailbox slots at an apartment building. So when you go into an apartment building, if you were a mailman and you had to deliver the mail into an apartment building, you'd walk up to an array or grid of mailbox slots, and you'd put like data, mail, in each one of those slots. So what would happen is you'd look at the mail and it would say, hey, I want to go into apartment 1805. So you'd find that mailbox slot and put it in. And then you want to go to 103 and put it in there, and 205 and put it in there. Now, the point is this block of mailbox slots is organized. It's an organized block that, as a mailman, you can very quickly find and navigate through the block to know where to put the mail. Imagine for a second, just imagine this for a second. You just blew up all the mailbox slots into a big pile of rubble. And then you, as a mailman, you have to walk in there and you have to find 1705. You'd have to dig through the rubble to find 1705 and put it in there. Then you'd have to look for 503. You'd have to re-go through the pile and find 503 and put the mail in there. It would take you forever to deliver the mail to that apartment building. Again, that's the point. This organization, the ability to organize your mailbox slots into this grid, allows you to very quickly navigate through that grid. So back to our PLC, or our computer for that matter. An array is a grid of memory spaces, and it holds like data. For example, all dints, all ints, all booleans, whatever it is you want to store in there, all the slots, quote quote, will actually store the same amount, the same type of memory. So you define this grid, and then what you do is you store memory in and out of that grid. So you can navigate. The way we navigate, what you're going to find is your computer program, whether it's a PLC or whether it's a web page or whatever it is, whatever programmable device it is going to be able to navigate row and column, let's say, through that array. If I was to just go out and just call up my handy dandy paintbrush program just quickly to show you a picture of an array, just give you an idea. Imagine for a second you have a grid. We have different dimensions that we have available, and I apologize for the rough drawing. I'm just quickly doing this just to show you, but imagine this is what's called a single dimension array. It has one column of memory addresses, as opposed to a two-dimensional array, which is more like our classic Excel spreadsheet with multiple columns and multiple rows. So imagine something like that. Okay, that would be our classic two-dimensional array. Okay, or you could even go one step further if you wanted to, and you could actually do the you could do a three-dimensional array, which looks more like basically, if you remember a Rubik's Cube as a kid, it looks like a Rubik's Cube. This would be what's called a three-dimensional array. So let me just finish this off. So if I just quickly do this, couple of rows, couple of columns, but the real gold here in the three-dimensional array is because it actually goes back like a Rubik's Cube did. So you can see I'm drawing this loosely. Oh, sorry. I want to give you this picture of a three-dimensional array. So, I mean, I'm doing a really rough drawing here, a real rough drawing of this three-dimensional array. You can see what it looks like, but it looks like a Rubik's Cube. All right, and I don't want to spend too much time doing drawings, doing a silly paintbrush drawing, but you get the picture, right? The point is that you can visualize these arrays in this fashion. Okay. Now, of course, in the PLC memory, it's going to be more of a linear type memory that we're going to see. But bottom line is, we have the ability to format our memory in a grid-like fashion, and by far, no doubt, by far, these two are used more often. Very seldom do we ever see a three-dimensional style. Okay, so what could we do with something like this? So let me delete, see if it'll let me delete this. Delete that, and let me delete this here. So imagine I have an array like this that I want to actually store information in. What I can actually do is, for example, maybe I want to store the a recipe in here. It's gonna actually have a recipe or a bunch of recipes. Let's say this is actually, you know, hundreds of array elements long, and what we can actually do is have this array supply the recipes for a working array. So maybe we have a smaller working array over here that's actually what we're going to use in our day-to-day operation. So the example I always use, one of my favorite places to ever go for automation was a cookie place where they actually made cookies. So it's a local company that made cookies, and I walked into this place, and sure enough, the smell of the cookies was just fantastic. It was a great place to visit. But they had like 3 or 4 lines of cookies that they would be making at any one time, and you can imagine. So one line was making you know, chocolate chip cookies. The next one was making oatmeal raisin cookies. The next one was making peanut butter cookies. The only thing different between these lines is the recipe of the ingredients that was put in. So each one of these lines is exactly the same, and what happens is they would pull their recipe from let's say this grid, this large recipe database. They would pull it, and then any one day they would, let's say they would use this first part for the first recipe for today. Then tomorrow maybe they'll pull this recipe down here and use it. And then the next day, maybe they'll pull the recipe from down here and use it. Okay, so the point is you could store your recipes in this array and then grab the data whenever you need it. Sure, that'd be one use for it. Well, that recipe could be, as you see here, it could be a single dimension array, as we have single dimension array, or let's think about a multi dimension array. So yeah, the computer's not letting me do this. So anyways, I'm going to go in and just make a new grid like this. Imagine multi-dimension array. So it's got multi dimensions to it. So again, I don't want to spend a lot of time drawing my grid, but you get the point, right? Imagine you have all these array elements, and maybe this one here is meant for the macadamia nut cookie, and this one here is for the peanut butter cookie, and maybe you have another row and column over here, set of rows and columns for chocolate chip cookies, and so on. You know, position 0 could be how much sugar is put into each one of these cookies. Sure, that's another way you could organize your data. The point is you're organizing this data, and then you're going to very quickly store and retrieve it. So maybe in our case, we're going to grab it out to use it for the machine to actually do the work, or maybe production's going to use it to edit the ingredients for a recipe. Maybe they want to start using more chocolate chips or less chocolate chips or something, or less sugar or something like that. Production could also write to these arrays. So that's where arrays really become powerful. That's where we use them. It's a way of very quickly navigating through that grid of memory. Okay, let's go out. Don't save that. How do we make an array? How is an array made? So let me actually go and create one. So I'm going to create a tag called my array, because an array is just a tag. All right. And here's where it's going to change. I'm going to right click and go input assistant. Sorry, not input assistant. Actually, what I'm going to do is go back. I'm going to say refactoring add variable. I'm going to add a variable, and I'm going to come in here and say my array. This gives me this add variable auto declare window. We can also get that from up here under the edit menu, but that's just how I chose to get it, was right click. Okay, my array. And what I want to do is I want to come over here and hit this arrow button, and you'll notice there is an array wizard. You want to use this. And you can then go in and decide the size of each of the dimensions. So the first dimension, let's say, is the first layer of it is, let's say, from 1 to 9, or 0, sorry, to 9. That's the first dimension. If I was making a two-dimensional array, maybe it's going to be 0 to 3, right? 0 to 3 for argument's sake. And if I was doing a third dimension, I could do that. Okay, you know what? I'm just going to make a single dimension array for now. And the data type that you're going to use, because of course arrays are based on all the same data types, right? An array is going to be based on some standard data type, for example, a dint. So as you can see, it's making this array for me. It's going to make a tag called myArray that's going to be an array 0 to 9 of a dint. And I'm going to say OK, and it will put that in there for me. Okay, myArray. Okay. Okay, now, how do we work with the array? What's an example of using this array in your program? Well, let me go out and grab a move block. So we remember what a move block is, right? A move block is nothing but a memory function which moves data from one location to another. So for example, maybe I want to move my tag, the value of my tag, into array location 0. Well, let's go do that. My tag into array location, my array, square bracket, 0, square bracket. That's going to move that data into that array for me. Now, maybe I do that when I don't know. Let's do push button 0. When push button 0 gets hit, I move it into my array 0. So let me take that out, and let's do it with a couple of push buttons. Well, what if I wanted to do push button 1? Maybe push button 1 moves it into my array 1. Whoops. And push button 2 moves it into my array 2. Oh, for some reason I didn't declare that. So let me go do that. So I'm just going to bear with me for a second, and I'll just finish up this program so that we've got all our push buttons in there and we're good. So it doesn't give me a problem, but you get the point. The point is you could have a selector that, you know, the operator presses push button 0 and it loads in, it takes my tag and puts it in my array 0. He pushes 1 and it goes into 1, and so on. And you can put it into the different array locations. All right. Okay, what if you had an array with 1,000 elements in it and you wanted to do this dynamically? Here's where the real power comes in to our array is the ability to do what's called indirect addressing. So let me delete this. Instead of doing individual move instructions, what we could do instead is we could actually put a tag in here, call it, let's say, my pointer. I'm going to call it pointer. That's what most people call it in when they use this in any programming language. They use the name pointer. So I'm going to use pointer, and it's going to be a dint, and that's going to give me a reference to what location I want. So now here's the neat thing: when I push button 0, if my pointer is equal to 0, it's going to move my tag into my array 0. All right. If I set my pointer to 5, for argument's sake, when I press push button 0, my tag is going to be moved into my array 5. So it's going to give me a way of dynamically going through and navigating through your different your locations. So you could have, maybe you've got an HMI screen where the operator selects which location he wants to write to. He presses the button on the screen, which sets my pointer to, and it points it to which location we want. And then when he presses push button 0, it writes the tag across. We can do that with just one move instruction now. We don't need 5, 10, or 1,000 move instructions. Okay, let's have some fun with this. I like having fun with this. Let's go and try something. Well, first of all, you know what? Let's actually download this. Let's actually just try this so you can see this actually working. So if I close this and I come down here, I'm going to open up my array. So if I say run, I'm going to run the program, and I'm going to put a value in my tag. Let's put 12 in there just to have some number. Okay, so write the value of 12 in there. So my pointer is equal to 0. So let me change that. Can I change that here? I guess I probably can't, right? Let's see. Let's go offline. Let's go offline. Let's actually default this to 5, just to give it some number. Okay, just so we see something different. Let me download that again and try that again. Okay, so my tag I'm going to make equal to 12, and then you can see my pointer is set to 5. So it's going to write to location 5. What you're going to see is location 5 is going to get 12 when I actually write PP0. Oops, sorry, I got to turn it on so you can see there. Okay, so 5 gets the value of 12 because it's writing to my array 5, which what it's writing to. It's writing the value of 12 into my array 5 is what it's doing. Okay, so that's what's called indirect addressing, and sure enough, indirect addressing is used all over the place. It's a very common thing to do. Okay, so as I said, let's go have some fun with this. What I've got is something interesting. I've got a timer counter here. I've got a timer counter that's actually going to just count. It's counting up to 10 every second. It's going to count up to 10, and then it's going to reset itself. So if I log in and show you this, you can see it's just counting up 5, 6, 7, 8, 9, and it's resetting. I want to take counter up, and I want to use it for my pointer here. I'm going to use it as my pointer. Instead of my pointer, I'm going to put counter up in there to get it to dynamically cycle through all the locations in the array for me. Now, to get this to work, one of the problems is this tag is local to the timer counter POU, and we have to get that value into this PLC program POU. The easiest way to do that at this point, I mean, we could go make a function, we could go do that, and that's one way to do it, absolutely. But what I wanted to show you at this point is an application of the global variable. So let me actually go through and create, I'm going to add a global variable list. call it GVL, and in there I'm actually going to create a tag called my count. It's going to be a dent. Okay, and instead of using CTU 0CV, I'm going to use GVL dot my count. I'm going to use that tag. Now this program is going to write to the global variable called my count, which then I can use back in my other program here as my pointer. Instead of the tag my pointer, I'm going to actually use GVL dot my count. Okay. And as a matter of fact, let's turn off PB0. Let's take that out of the question altogether, out of the equation altogether, and let's try this. Log in, download. All right. And sure enough, I got to push play. And of course, let me go back out. I push play. You'll notice that this is running. My count is running. So if I go back here, you should see my count actually changing. See that here? It's actually changing. So the pointer, the location it's writing to is changing. So right now I'm writing zeros across, but let me go and change this. I'm going to change this to some value, so 14. And right click, and you'll see, depends on where it is at the moment, it's at 7. So it's going to start writing. See that? It's writing 14 in. And it's doing that based on that timer counter combination. Okay, so let me change this to 159. And you'll see that change. Whoops. What's interesting is, what's fun about this, if you really want to have some fun, let's see how fast we can do this. So if I'm going to change this to, instead of 1 second, I'm going to change it to 1. Let's see if can I do 1 millisecond? Let's try that. See if it takes it. Oh, it takes it. It likes that. It's going to write really quickly. So let me go and put a number in here. Let's watch how fast this actually writes when I do this. Watch the array. Once I click it, I'm going to go 3, 2, 1, click. And it writes them. So it's doing that very quickly. All right. So in 1 millisecond, it's basically 10 milliseconds and it's done here, right? Okay, so that's pretty cool. That's pretty cool stuff. Let's go offline and try something else. So that's the use of the global variable to pass data between the two routines. Let's go do one more thing. Let's actually go. We'll just use it local. We don't need to go global on this one. But let's go and do. Let's go. I'm going to move these up so that they're tightened up, and give me some space. And I'm going to go and I'm going to make a user-defined structure now. So of course we can make an array, we can make standard data types, all the regular data types, but we've been pretty isolated to specific data types. What if we wanted to make our own data type? What if we wanted to go out and make our own structure? So like a timer or a counter and this structure where it's got different parts to it, what if we wanted to do that ourselves? What if we want, I don't know, let's say we wanted to make a structure that represents, some data for an AC drive. So for example, we have the start, we have the stop, and we have a speed reference. The start and the stop would be Boolean, right? Well, the speed reference would be an integer of some type. What if I wanted to actually make my own structure that I could use as a data type for a set of tags? Well, let's go do that. To make a data type, I right click and I can add an object, and it's a DUT, data type, data unit type it's called. And I'm going to give it a name, drive. And it's going to be a structure is what I'm going to use. I'm going to create a structure. Structure is a standard structure like a timer or a counter where it's got different parts to it. Enumeration is a little different. It's more, it basically allows you to define a set of constants in a single tag. An alias is used with real I/O to give it a tag name to connect them. All right, and a union is just another type of structure. But bottom line is the one we're going to use at this point that I want to cover at this point is the one called structure. And I'm going to make a structure and I'm going to call it a drive structure. Say OK, and it creates the structure. See that over on the left side here? Now, what you do is you go in just like you would with a variable table, and you go and you define the different parts to it. So Boolean, start, stop, and let's say speed. I don't want to go too crazy. I just want to do a couple of different data types just to show you what's going on here. Okay, so that's my data type. Now here's the really cool part about this is back in my regular program, all my other programs, I can call or use that data type. So drive 1, it's going to be of data type drive. Okay. Okay, well, all right, so I don't get it. Let's apply this. Let's actually do something with it. Let me go and put a couple of networks down and let's try this out. So what we have now is we have parts that we can work with. You remember like in a timer where you have ton_0.q, we have the separate parts to it. Well, we have separate parts now. We've just created parts to our structure. So the start and the stop. Let's say I've got push button 1. I'm going to use that as my start push button for my drive. So I'm going to come over here. I'm going to type drive 1 dot. And when I do that, look what it does. It gives me the parts that I defined. Start, stop, or speed. Of course, it's a Boolean. So this is a coil, so it has to be a Boolean. Let's do that for the stop. Same thing. Okay, so what? So, big deal. Here's the real advantage of this is the ability to do multiple drives of that same data type. So drive 2 is also a drive structure. And guess what? If I go in actually, what if I wanted to use these to turn on and off both drives at the same time? I could copy this and paste it, and I could go and change this to drive 2. Oops. I could also do drive 2 start. And the structures, the point is that you're maintaining an organization of the structure of each drive, so people can find where the tags are, where everything is. It keeps things organized. It really makes it nicely organized. And you know what? If you even wanted to go one step further, what if we had 10 drives? Well, we just talked about making an array, so you can make arrays, right? Instead of doing drive 1, drive 2, drive 3, drive 4, what if I did this instead? What if I did drives, and I'd say that's an array, and I'm going to say 1 to 9. I'm just going to type this in, 1.9. I'll just type the format in right raw of drive. This is really interesting. Look what I do over here. Let me go and type this. I'm going to put the square brackets around my numbers here, and that's going to give me my array now. Oh, come on. Sorry. Now I can do drive 1, drive 2, drive 3, all the way up to drive 9. I could actually say, I could come in here and say 900, 1 to 900, and have 900 drives if I want. And they'd all be of that same structure. So it would create an array based on that structure. So this is a really, really powerful tool. The idea of making your own structures and then being able to use that, leverage that, and then of course making an array of those structures just takes us right out, just accelerates us right up. It's just a fantastic function that you have, programming function that we have available to us inside our Codesys. And you know what? To be honest with you, this is a function that's in a lot of other PLCs as well. Rockwell has it, Siemens has it, Omron has it. They all have this now. So it's all the same type of idea. So once you learn that here, you're going to be able to apply that in other situations. Okay. All right. Well, thank you very much for coming to this video. I appreciate it. Um, this video on data types and complex, basic and complex data types. Please do me a favor and like the video at the bottom of the screen for me, and then and also share it if you could. Also, I've referenced put my name, my email address on the blue screen that happens at the beginning and at the end of each video. By all means, if you have any other questions going forward, please don't hesitate to drop me a line. I'm going to be doing other videos and other classes. So whether it be Rockwell and or Siemens, I might also be doing a full-on Codesys class. So if you're interested in a larger Codesys class, please email me, or any other classes, please email me, and I'll be more than willing to put you into my private list and get you hooked up with the different courses. Okay, take care. Thanks. Bye.